Welcome to the Cloud Native Testing Podcast. I'm Ole Lansmar, your host, and I've spent years building testing tools like SoapUI and Swagger, and now I'm the CTO at TestCube, where we're redefining testing for the cloud native landscape. In this podcast, we invite people in the space to discuss with us the challenges, solutions, and best practices for testing in Kubernetes and beyond, covering automation, CI/CD, GitOps, and more. This podcast is proudly sponsored by TestCube. If you're interested about how to test cloud-native applications and infrastructure, subscribe and stay tuned. Now let's dive into the episode. Thank you for joining. Hello and welcome to another episode of the Cloud Native Testing Podcast. I'm super thrilled to be joined by Benjamin Wilms today from Steadybit. Ben, welcome to the show.
Thank you very much, and thank you very much for having me on your episode.
Of course, it's a pleasure and an honor. So please tell us a little bit about yourself and where you are, what you're doing.
Yeah. So I started my career around 25 years ago as a software engineer. I worked at different companies, started in the logistic area, then was able to get into consulting engagements and learned a ton of stuff. And while talking about learning, most of the time I was able to learn something out of a failure, when something isn't working as expected, because that's a nice opportunity if you are surrounded by the right people, the right culture, to really learn from it. And this was the point where, around 8 or 9 years ago, where I realized, hey, there's something called chaos engineering. And that's like, you can learn from failures. And so that's why I started with chaos engineering around 9 years. Now I'm the founder and CEO of a company called Steadybit, a chaos engineering platform.
Okay, cool. That's very cool. Yeah, I'm just as you were talking, you were saying like 8-9 years ago, this chaos engineering, maybe emerged as something more generally available, or people to general awareness. And to your point, maybe it's like, because we've always been saying, learn by failing and fail forward and these kind of things. But this is maybe the first thing where you're actually trying to fail and embracing failure as a way, or provoking failure as a way to kind of evolve and learn, versus, hopefully not having failures. And if they do come up, you learn.
Exactly. And that's like this transition, this other type of mindset where you really want to inject something bad to validate if your system, if your organization is able to handle such an outage, is able to, let's say, survive some bad stuff on your cloud provider setup, whatever. I mean, hope is not a strategy, and we shouldn't run our systems based on just hope.
No, hope is not a strategy. That's good. Okay, great. So just tell us a little bit more about Steadybit and just in the context of chaos engineering and maybe how it's different.
So with Steadybit, or let me do one step back. During my time as a consultant, I was starting with chaos engineering at many different companies in Germany. And I was a consultant, I was doing some workshops, but also I was helping people to get this thing up and running. And then I realized, of course, there are nice open source tools on the market, there are some other tools on the market, but I was wasting so much time and energy on setting things up and just then to start chaos engineering. And at that point, I was able to see, okay, you can do something differently. You can build something where you should focus on your use case and not like on the tooling or not on how to get this in my pipeline, whatever. No, you really need to test your system. You really need to train your system and your organization and not wasting endless hours in tooling and setting it up.
Mm-hmm.
And that's where Steadybit was founded in 2019. And that's our mission, to really provide something for non-experts in the chaos engineering space to get started, to really improve your organization, improve your system, and be more reliable.
Okay, that makes sense. So I guess I have a lot of questions. We'll just start. I mean, one thing, at least initially, it felt like when chaos engineering emerged, it was something meant for very large scale infrastructure deployments and topologies. But looking at Steadybit and other tools, maybe it feels like it could also be used in a much, much smaller context where you don't have that massive infrastructure. Is there like a lower limit, or do you feel like chaos engineering can even benefit at a very, very early phase when there's really not a lot of infrastructure to speak about?
So there's not one unique point in time, or it's not like you can only do it if you are running thousands of containers or microservices or whatever. No, there's something in it for everyone. So we've got customers that are just, it's a small group. It's just 6 to 7 people. They are getting started with a new idea, with a new product, but they want to be, able to trust their system. And also, I mean, it's a small group of people. And so they need to build the stuff. They need to operate and run the stuff. And so there shouldn't be a surprise in the operation. And then there are very large organizations, as you mentioned. I mean, in the old days, in the beginning, Netflix was one of the well-known companies that is doing chaos engineering in production. To be honest, no, everyone can do it and everyone should start with it. And I mean, you can do it without any tool. You can just, let's say, enter your virtual machine and shut down. That's all.
That's a very, very manual, but very concrete way of, I guess, getting started. Another thing you mentioned here, so I'm thinking about, to me, it felt like chaos engineering is maybe more an operational concern, or the ops people who are responsible for the availability, etc. But in testing, we've talked about shift left a lot. Is there a overlap there to kind of shift chaos engineering left? Is chaos engineering something that can be done earlier in the SDLC, or when in your SDLC does it really kick in and maybe add value?
Let me answer this question a little bit different. If I talk about a system, or like what is the definition of a system, I'm not only talking about technical components or the software or whatever. No, a system is, of course, the software, but also your pipeline, the process, the people that are needed to build that stuff, operate the stuff, deploy it, run it in production. It's like the organization, everything. And it's a team sport. It's not only done by one group. So, of course, there are people that are more closer to production and they are more hunted by production because everything will break, everything is collapsing. So there's a big pain and a big need that they want to get out of that cycle. But an SRE, as an example, is not able to fix everything. He needs the support from his engineers. He needs the support from the organization to really, get the system in a better situation.
So, but if I'm let's say I'm a developer at a mid-sized organization, I'm responsible for working on a handful of microservices, which I write my code, I push it to GitHub, I do my pull requests, etc., and then some pipeline kicks in. I think spontaneously, I would feel maybe before talking to you at least that chaos engineering happens later. But how could I be more involved then? Is it just a cultural thing about awareness, or is there a tactical thing that I could be doing early on while I'm building to somehow cater to a chaos practice?
So if you start from the developer perspective, stop with happy path testing. That's like the first step. I mean, your system or the component you are working on, of course, in your unit integration tests, they will work. Yeah. Maybe you are the guy who's writing the test code. So you need to be aware of all the bad conditions about latency, about corrupted packages on the network level. All that stuff will happen in production. And then you need to build your component in a way that it's still able to do its job. And that's what I mean with stop happy path testing, because everything will be green under those conditions.
Yeah, and I'm guessing, especially with cloud native infrastructure where, it's extremely dynamic and fluid, it's really hard to know the actual state and the performance of the infrastructure that your component is going to be running in at any given time. So
exactly. And you can imagine the system as a very dynamic element. It will change the dimensions in every angle. And so sometimes there's more load from the customer side. Maybe there's a new feature coming up. So the system is constantly in a changing situation.
It's constantly evolving. Yeah, definitely. Is there some way to kind of, if I'm just running locally once again, sorry, kind of homing in on the developer here.
Yeah, sure.
Some way for me to simulate those conditions where I'd say so I don't have to wait for a chaos test to happen later on. Can I locally somehow put my system under test in the sense that I slow down the network, or I don't know if there's some way to help me prepare for building a more resilient component?
Yeah. So if you, for example, are writing your integration test, you can use some open source components like, let's say, ToxiProxy, which is a component where you can simulate latency. So let's assume you are calling an external service in your integration setup or test, and then you can slow down the network traffic. You can slow down how many requests are being handled. All that is doable as a developer. But I will be honest. developers, I'm myself still an engineer by heart. Developers don't care about security or reliability until there's a bad moment, until something went wrong, because then they are in charge to get this sorted out and fix it. But I mean, as of today, developers are more measured on feature velocity, how fast they can get a new feature into production. So that's the main motivation. But I mean, yeah, there will be that point in time when you are just following this pattern that you will realize, damn, now we created a monster and this monster is running in production.
Yeah, I think one of our previous guests talked a lot about mocking and simulating external services. And I guess there is, as well, you could, configure mocks to, stochastically return errors, etc. So that's maybe a kind of chaos
But
testing.
to be clear, that's one step, because later on, and that's where chaos engineering is so valuable, you need to test your system as it's been deployed and running, and not like every component on its own. You need to see the full system.
So it does, I'm sure, I mean, as many things boil down to culture, at least to some extent. I'm thinking, how could you foster that kind of culture then? Is it to involve the entire engineering organization in chaos experiments, or is it to integrate like automated chaos testing into the pipelines so it's always there and helping you? What do you think? Do you see any specific practice?
So to start with an automated way, your system should be in a good position, because, as an example, there are some customers that are running 2 or 3 game days in a year with Steadybit. And after a game day, they were able to identify big findings, and it will take them about 2 or 3 months to fix that stuff. So if you now just do everything automatically, you will create a big list of situations or findings that you now need to fix. But I mean, that's not a good practice. First of all, get your system, get your organization into in a level of confidence that the system is able to handle some easy outages or so. And then you can think about, okay, let's do it with a pipeline after every deployment or whatever.
Okay, so you mentioned game day there. That's a new term to me, I have to admit. So please, can you just elaborate on what?
So a game day is really like an exercise where everyone is getting together in one single room. And by talking about everyone, this means the SREs are coming, the engineers, the product people, and how to be politely, the people in charge, the decision makers. They also need to be there, but just as an observer. Why? Because, I mean, we as engineers, we are always talking about technical debt. There is something in the system. It's not visible, but it is in there, and we should fix it. But then the decision makers or the budget owners are coming in. No, new features first, new features first. So with the game day, you are now able to get everyone in a room, and you will talk about a potential scenario you would like to execute. And the scenario could be, let's imagine you're running Kubernetes managed by your cloud provider. Let's simulate a zone outage. And then with all the people in the room, you can design this experiment. But the key element is they can learn from each other, because hopefully there will be someone in the room with like this good overview about the system that will tell you, hey, we don't need to run this experiment. I already know that we will fail. And there's one principle in chaos engineering. If you already know your experiment will fail, don't execute it. I mean, there is already a learning opportunity. So first fix it, and then use your experiment as a verification step.
Okay, that's interesting. And so the outcome of a game day would in the best case be failures, I guess, or a list of things that a manageable list of things that to fix or improve in your system.
So the outcome is not a failure. The outcome needs to be a finding. You will inject a failure like an outage, but you want to learn how your system reacts.
Okay. But, and then leading to, like, is there even a case for automated chaos testing, or does that kind of defeat the point?
No.
Okay, so how would that be done in a pipeline, and where in your pipeline would you do that?
Let me maybe describe the journey or the flow of an experiment. So you can start in a game day, you can design the experiment, you will execute the experiment, and at that point in time, when the experiment is not failing, because an experiment is like a unit test, it will be green or red, nothing in between. So if it's green, okay, perfect candidate. You can use this experiment to put it in your pipeline. And then after every new feature, every new release, every new build, however you will decide, you will trigger this experiment. And then this experiment is more like a regression test. You will execute it every time after new deployment. And so you can now use this experiment to verify if you are getting in the same situation again and that your system is still able to survive under those conditions. If not, you're not safe.
So that sounds super intriguing. It makes a lot of sense. So what kind of, can you just give us some examples of what these experiments could be?
Let's start easy. Kill something, shut down something. That is like the easy one. So you can, let's imagine you are running, getting back to Kubernetes as an example, you are running a Kubernetes cluster, at least with 3 nodes, shut down 1 node and see what will happen. But it shouldn't be a surprise. Before you shut down that node, you should describe your expectations. You need to describe your hypothesis in a way that, let's say, I expect my system to react like this, even if 1 node has been dying or been killed. And so that's your verification point. That's where you can really see if the system reacts as designed. What else can you do? I mean, you can use some tools. You can use, there are open source tools like Pumba or ToxiProxy, or even just on Linux level with IP tables or whatever you can imagine. You can simulate a DNS outage. You can mark packages as corrupted. You can throttle the bandwidth. So there's so much stuff you can do.
Okay. And I think you mentioned early on there could be a distinction between running chaos experiments in production versus in a like pre-production environment. Is the ultimate goal always to be able to run them in production, or is that like a necessity for you to do chaos engineering successfully, or is it more of a nice have?
So you should be able at some point in time to run in production, but it depends on your industry. So let's say you are a financial institute or so. You're not allowed. By any chance, you are not allowed because it's not your money, to be honest. But as another example, we've got a customer where they are running a gaming system, and this system is so massive, there is no test system. They can just do it in production. And that's why it really depends. But you shouldn't start in production, to be honest. So if you are doing it the first time, start earlier. Start way earlier in your stages. Even on your local machine, it's a good starting point to get the first feeling about how this will impact your services. But at some point in time, you should be able, and you should do it in production.
Fascinating. It feels to me like Kubernetes really is a big enabler here for chaos testing, because it's so easy to declaratively mess with the configuration of your clusters. Is that true, or is Kubernetes just like any other?
Kubernetes will help you to already implement a lot of resilience patterns automatically, because based on the underlying architecture. But I mean, as an example, let's say you are using Kubernetes and your pods are distributed across all the nodes, but this cluster has been managed by a cloud provider. So you're not really in charge where this node has been located. So as an example, 3 nodes, you will kill, let's say, or 1 pod will die or 2 pods will die for whatever reason. And then it's not visible for you to see really how the pods are distributed across all the zones you are running. So this means if there is just one single zone you're running a Kubernetes cluster in, and there is something going wrong in that zone, I mean, what should you do? There's no way around. You need to distribute your pods across different zones to be really reliable.
Resilient, yeah. Okay, that's interesting. I'll have to ask about AI because it's such a hot topic. Does AI play into this in any way? Can you use AI to create experiments or to learn or to, I don't know, but I'm sure that's something that people ask.
Yeah. So right now, to run experiments and execute them with AI in a running system, people are afraid of. They don't want to do it. But AI can help you to get more insights about what your system looks like, or it can help you. Let's say we've got people that are running, what is it, 60,000 experiments in a year, and they want to get insights out of it. That's where we can help them with AI features to really see, okay, your experiments failed because 200 times there was something like this. So getting insights is very good. But people are also talking about, with AI, you can create a system, you can change a system on the fly. And so with AI, they need to really be confident that this constantly changing and now influenced by AI stuff will be able to survive. And I mean, again, hope is there not a good strategy. And so you should use something like chaos engineering to really make sure that the last changed, even if what was done automatically, is really not hurting your system.
Interesting. Is there some chaos testing at the AI, like LLM? I'm thinking like agents level, where you would, if you're building an AI stack where you've built your own agents, etc. Is there some chaos testing aspect there that you're aware of, where you might want to make sure your LLMs are resilient to changes in the underlying, I don't know, architecture application?
I'm not quite sure about the LLM so far itself, but the underlying infrastructure or the GPUs that are needed to really execute all that stuff, there is a way also with other open source tools and Steadybit that you can inject load or really influence how the GPU has been operating. But I'm not aware of any LLM so far.
Okay, let's just thinking out loud here. Okay, thank you. And what about the future of chaos testing? Do you see anything specific? I mean, AI maybe is part of that. But are there any other like trends or things that you see how people are adopting it, or just on a technology level?
So there will be a shift where the chaos tools will help you more in the pre-experiment phase, where those tools are getting insights about the actual system and they can highlight potential weak spots in your system based on some data the chaos tools have already discovered. As an example, inside of our tool, there is a feature called advice, and this advice feature will use the data from your system, and we can highlight areas in your system where you should improve because there is already a risk. And so you don't really need to run experiments, you don't need to do game days. They are all quite time consuming, but a tool will help you to improve automatically or will show you where something can go wrong.
Okay. Okay, just finally, I wanted to ask. I mean, I think when I listen to this, I'm like, oh, we have to start doing more of this test cube, and I'm sure others listeners will feel the same. This seems, it makes so much sense, and seems to be so straightforward. How do you start with something like this without getting kind of overwhelmed, maybe with that it's actually harder than you thought, or it requires more effort than you initially thought? Is there like a way to ramp up into chaos testing?
I would start with any platform approach. So a software which will help me to focus on the experiment and not on all that tooling stuff. So there are tools out there, not only Steadybit, but also other tools where you can sign up, you can use them, you can get started. And those tools will hopefully help you to start your first experiments without any big ramp up time.
Okay, and I'm guessing culture is a big part of it, just the awareness and
culture
openness
is a big,
too.
and you need to be surrounded by a culture where an incident is a learning opportunity, where something, it's not like finger pointing, hey, you have done it wrong,
Sure.
it's your fault. No, we as an organization, we as a system, we can improve ourselves from an incident.
Okay, well, okay, awesome. Benjamin, it's been great having you here. I've learned so much. It was fascinating to hear about chaos and all the things you shared. So, and thank you everyone for listening. And I think that's it for today's episode.
Thank you very much.
Thank you. Take care.